Welcome back everyone. Today we're going to be starting regression. And the regression is the process of fitting a straight line to the bivariate data. And we use the least squares method. That's one way of finding the equation of the regression line. Now this minimizes the sum of the squares of the residuals, and it's best when there are no outliers. Now here we have our line drawn in when we have all our data up, and you can see x1 and y1, that's a point, and then x2 and y2, that's a point, and so on and so on and so on. Now the regression is the distance that minimizes, so the minimum distance from the point to the line. Now of course this part here that I'm just marking there is a negative distance. The d2 going from the d2 to the x2, y2 is a positive distance. So above the line it's positive, below the line is negative. And we want the smallest distance, so the minimum distance from the line to these points. And these distances are known as residuals. As I said, the least squares line is the line that minimizes the sum of the squares of the residual. Now there is a formula to work out the equation of this least squares regression line, and the formula is given by y equals a plus bx. Now b is the slope, so in other words the gradient of the line, and what we need is r. Well, we've already know what r is, that's the correlation coefficient. Sy, which is the standard deviation for the y, and Sx, which is the standard deviation for the x. So remember, it's a point, you have x and y. And the a is the intercept, and we find that by getting the mean of y minus b, which we find, which remember is the slope above, and x mean. So we need all those, and we just use these two formulas and then substitute it in. Now, we have to do exercise 5a. We're not using the rule at the moment. Our next lesson is where we're going to show you how to use the rule.